Hi everyone, welcome back to this channel. This quick video, I'm going to show you a walkthrough on how to set up a relatively new VXG M9484C where it has multiple output, phase coherent, but we won't cover that part in today's video. So in this video, I'm going to show you how to set up this VXG to generate a string of different type of signal within the same bandwidth. So this is how it looks like, default, and of course without all this signaling. Let's preset it. And this is how it looks like. So as you might have guessed, we have two channels output here on this VXG. So there are two ways of generating the type of signal that you want to transmit from this VXG. First of all, you can use what's available over here. So we won't go through that yet. I'm going to go through the type of applications that's available in this VXG right now. So all these applications is just a Signal Studio. So it's powered with Signal Studio for different type of technology, and you can actually download and install as an app in this VXG. So we have custom modulation. So this is where you can generate simple modulations such as QAM. Then you can change the symbol rate and whatnot over here. So most of the parameter you can change over here. So this is one way of doing it. The other way is to use the IQ tools, which you can download from keysight.com. It's free tools, and we have this thing here. And I'm going to turn off the pause apps that I just used just now. So anyway, this is IQ tools, which you can download from keysight.com. It's free, but it only works with certain type of instruments, especially for the signal generator. Let's focus on that right now, because anyhow, we need to generate the type of signal to be transmitted on this group 1 on the VXG. So let's go through the IQ tools. So assuming that you have installed IQ tools and this is a runtime, you don't need to have the MATLAB license to run it because this is an executable file. So let's go to instrument configuration. So this is the first step where you have to make sure that this software does talk to the VXG or any of the signal generator that you have. So for this video, we're focusing on this M9484C. So first of all, you have to make sure that the generator that you have is part of the list here. So you can see that M9484C is part of here. And of course, you can work with M8190, which is AWG if you want to. And let's click on that. So currently 2 channels coherent if you want to do that, but I'm just transmitting out from 1 channel, so it's not a critical setup for me right now. So by default, it goes with the VSAR connections. So somehow I found that we have to set this VXG to high sleep in order for this VSAR to work, but with the current setup default, I haven't changed anything set up over here. I'm going to create another video just to focus on the VXG buttons walkthrough so that you can see the interface, how it looks like, and where the setup is. Once you change the connection type to TCP/IP, and then because this is running on the VXG itself, so it becomes the local host. So you can type localhost or 127.0.0.1. So we're going to test the connections, and if it's passed, it will become green. And of course, if you want to do digital pre-distortion type of corrections, you can have a spectrum analyzer connected or a real-time scope connected or digitizer. So it depends on you how you want to do it. But for this video, I'm going to walk through pretty fast because I want to stay within the timeline, and we won't focus on that. But if there's a time, I'm going to set up here so that we can see how to do the digital pre-distortion corrections here. Then you click OK, and I want to generate multiple pauses within the same, let's say 1 gig bandwidth. So I go to radar pause and chirp. So this is my main focus today. Before we jump into that, I want to try on digital modulations because I want to see the effect of the sampling rate towards the bandwidth of the signal that I'm generating. So before we jump into the pause, let's change this. By default, this is sampling rate 3 GHz for this VXG. So we do not want to occupy the whole thing. If by default you didn't change anything here, you can only generate 1 signal, and because it's occupied the whole bandwidth. So let's start with 10 megahertz. So we have 10 megahertz here. I won't change anything here. QAM 16, that's what I want. You can visualize it in MATLAB if you want to before you download it. So you can have the CCDF, you can have the IQ spectrum, how it looks like, and the IQ waveform. And once you're happy with that, so we can download that to the VXG. So this is where it comes in when we want to run a calibrations digital period distortion with the transmitter. But we are not doing that today. Let's do a download. So it will pop out setup for the output. So let's say we set it to -10. Center frequency at 1 gigahertz. And segment name, you can change that if you want to, so that you're going to see later how does it affect the tower signal. So we click OK. And there's a baseband generations overload. I won't fix that for now. Anyway, let's go back to the VXG. So as you can see here, we have modulation on, RF on at 1 gig at -10 dBm. So this is where you can change the frequency offset. By default, it will be at the center at 1 gig, but because we want to have the whole long list of different type of signal transmitting at the same time, so we can put it as an offset. Let's say we minus 200 megahertz. So we start from 800 megahertz. And attenuation is relative to the transmitter power from the channel output. So you can change that if you want to. To me right now, we just leave it as it is. And this is where you can change some of the parameters also, because we created the waveform file and then recall it from this VXG, so it's part of the waveform file selections. So, and this is a frequency offset. If you remember, we just changed that. So sampling rate, we're going to change that, and then you're going to see the difference there. So I'm going to turn on my spectrum analyzer, which is connected to this VXG. So I'm going to share the screen right now. This is how it looks like on the spectrum analyzer mode. So as of now, as you can see here, we have about 800 from here, and then we have about 5 meg to the left and to the right. So it's about 10 megahertz bandwidth for this QAM. So what if I change this to, let's say, 50? So as you can see that the signal bandwidth is actually increased. So let's change to 50. Oops. 41, 50. The sampling rate translates to the bandwidth of the signal of your interest. So let's go back to 10 megahertz. Let's change that. So let's change to 10 megahertz. So it goes back to 10 megahertz. So this is just one of the signal that I'm transmitting for now. Let's go back to focus on this. Right, let's go back to the VXG setup. So right now I have one signal here, 16 QAM at minus 200 megahertz offset. So let's say I want to create a pulse for whatever reason that you want to. So you can do it through the IQ tools, like I showed you just now. So that's what we're going to focus now, because for this signal type, if you want to create a signal, there is no pulse set up here. You can try real time, but I don't think it's there. Yeah, it's not that. And you can try the waveform file and then select the waveform file that we have created. But that defeats the whole purpose of this video, because it's a shortcut to that. So I actually created this one radar, but it's not what we want to show. Other than waveform file, you can try analog modulations. Analog modulations is mainly AM, FM. Yeah, you can do a square, but doesn't show much. So we have modulation type AM, FM, and phase modulation. It's not pulse modulations. Then single tone, multi-tone. Multi-tone is really just tones. CW, it doesn't carry any type of modulations. So this way you can change the tones, spacing. So let's go back to signal, summary. You might ask, why not use the apps here? I written on everything here with the license, but we don't have the pulse. We can go to custom modulations. We can try to change this to FSK. FSK is frequency shift keying. No, not quite that. So frequency shift keying is mainly for just frequency key fob. We can go to default, DVB, DVS2, APCO. I don't see any pulse here, and It's under quick setup if you're wondering where did I go. So let's go back to here. Really, we don't have a good pulse setup here. So what I'm going to do is to go back to the IQ tools. So as you can see just now, we did a digital modulations, create a 16 QAM. I think there's some setup here, so we've gone through that. Let's go back to the IQ tools first page. So we go to radar pulses or chirp. So again, the first thing we want to change is the sampling rate. We do not want to occupy the whole 3 gigahertz of bandwidth. So let's say we set another 20 meg. And this is a pulse width and pulse period. So this is a quarter of it. I don't really want to change that much, but of course you can change this S unit, frequency span. Let's tally it with the sampling rate. We can change that after that. First of all, we just want to make sure the waveform is there. So -10, carrier frequency, then IQ2, pulse, 25%. Yep, we can do that. Yeah, there's some setting that I need to go through anyway. Here we go. So as you can see that we have these two things. So it's overriding the first one. I still yet to find out how to change that. So let's say we want to add in another pulse at different offset frequency. Same pulse, but different offset frequency. So we select the waveform, and then we go to waveform file. If you remember, we call it IQ2's pulse 25% here. Select, and change the sampling rate to, let's say, 10 meg. The previous one was 20 meg, I think. And yeah, there's nothing much here. And then go to general. Then frequency offset, let's say we want to -100 meg, and sampling rate is 10 meg here, which is what we have. So we enable it. And signal group, you just see that these two are playing right now. So let's focus on the spectralizer right now. I'm going to enlarge this, and I'm going to change the frequency, range, span. So this 100 meg, so we can change it to 200 meg, and then you should see two type of pulses here. So this is the first one, 20 meg, and this is the second one, 10 meg. So let's do this. And so the first one, that's signal 2, this is signal 1, 20 meg. Signal 2 is 10 meg. So we have these two signals transmitting at the same time, outputting from the same output at the same time. And you might ask, what is this custom modulation is all about? We're going to go through that later. Let's add in another 2 more signal, or maybe 3. Let's go to this, and we can recall. So let's focus on this VXG setup again. So I'm going to show you something weird here. So let's go to waveform, let's recall the 16 QAM that we just created just now. So 16 QAM, let's say we set it to maximum here, 3 gigahertz. And we want to turn it on. You see that we are not able to turn on because it's grayed out. There are 2 signals occupying the first 200 meg. So what we're going to do, let's change the sampling rate to, let's say, 2.5 gig. And it enables it, and you can see that the whole signal is just doesn't make sense because it tried to occupy the whole 2.5 gig. We change it to 2.5 gig. Let's see how it looks like. So as you can see here, it looks weird on the spectrum analyzer. So let's see if I change it to 2.5 gig. So it tried to occupy the whole 2.5 gigs from a 1 gig center frequency. It doesn't make sense. So this is a whole QAM signal. So this is what will happen if you set the sampling rate wrongly. And let's go back to the VXG. So you have to do the calculations whether the sampling rate makes sense and also does it overlap on your existing setup. So for 16 QAM, let's say we want to do it a 15 megahertz bandwidth. And we want the offset to be positive side right now, or even at 1 gig. And it works for now. And we add on another 2 more, just to make it 5, so that you can see what's going on when we turn on all of it. And let's go to another type of pulse that I created, pulse 300 meg. I'm not sure why I changed that. So sampling rate, let's change it to 50 meg. And we have the offset of plus 250 megahertz, and then we enable it. Then we go to signal. Again, we create another FM chip just for fun. So FM chip, let's say we set it to 50 meg, and select it. FM chip which I created yesterday, MFSK. Let's go to there and go back to here. So we have all 5 signals turning on right now. Let's go to the spectrum analyzer to see how it looks like. So this is just too wide. Let's go focus that. So we have the offset. We haven't changed the offset. Let me change the offset without changing that screen so that you can see what's going on. 300 meg. So my last signal, the FM chip, is at 300 meg. So all in all, we are looking about 500 meg bandwidth. So I changed that to 500 meg bandwidth. So you have 1, 2, 3, 4. Which one is my 4th? Let me check in, sorry. 250 and 300 is not that far away. Let's do 150 megahertz on the 4th signal so that you can see. Yep. So we have 1, 2, 3, 4, 5 signals. So concurrently, let's say you want to see a better view in LTSA. It just happened that this PXA has the LTSA license, so we're going to see that 500 meg might be stretching it. If, as far as I remember, this one is 500 meg LTSA bandwidth. So let's say we have 1 gig carrier signal, and this is how it looks like. So we have 2 type of pulses here. If you remember, 20 meg, 10 meg. This is a QAM signal. This is just a normal pulse, and this is an FM chip. So we can actually move it a bit lower so that you can see the FM chip, how it looks like. Let's go back to VXG right now. So assuming that we have done all these things and we're happy with it, and then we can do our testing and we proceed on to create another signal. One thing to make sure is that you enable these modulations. It's like any other signal generator. If you don't turn on the modulations, it will just send out a sine wave, a CW. The other things to be aware of is this carrier signal and the amplitude. So as promised, I'm going to show you how can we utilize the custom modulations features over here. Let's say you want to create a waveform and you didn't install the IQ tools, which is very helpful. But if you do not have that, you can actually go to custom modulations and launch another signal studio. So this is the MFSK that I did, just a very quick setup. So you can go to this custom modulation, custom IQ, custom OFDM or 5G. Then from there you can change custom IQ special time. So preset, it has something different from what you can see on the app, on the VXG. So it's a bit different, same but different. That's how we say it over here. So radar is one of the things that I choose. MFSK, so this were the sweeping type, the last one that I created. So this is another way to create the waveform. You can use custom modulations here, or you can just go to here, custom modulation, same, different. So these are the walkthrough, and I hope you gain some insight from here. Thanks for watching.